up, everybody? This is Tech G back with another video. And in this video, we're going to be talking about what computer vision actually is. So let's get into it. Let's play a game. Look around wherever you are right now. Do you see your phone? Do you see a coffee cup? Maybe there's a dog lying on the floor or a car that's passing by outside. Now, imagine teaching a computer to see all of those things, not just to see them, but to actually understand what it's looking at. That, in a nutshell, is what computer vision is all about. Now, it sounds wild, but we're already living in a world where computers recognize faces, detect diseases in x-rays, and help self-driving cars figure out when to stop at a red light. So in today's video, I'm going to break down what computer vision is, how it works, and explore two foundational concepts in the field, and that is image classification and object detection. So whether you're brand new to this or you just want to finally make sense of these buzzwords, well, you're in the right place. So let's get to it. All right, so first things first, exactly what is computer vision? So let's go ahead and keep it simple. Computer vision, this is a field of artificial intelligence that trains machines to see and make sense of the visual world. We humans, we do this all day, every single day, without even thinking about it. Our eyes can take in the world and our brains interpret what we're seeing, whether it's a cat, a stop sign, or a facial expression. With computers, the process is more mechanical, but the goal is the same, and that is to help machines understand and act on visual data. Now, the next question is, why is computer vision such a big deal? Well, here's why this field matters so much. When it comes to healthcare, AI can detect tumors and medical scans faster than human doctors. When it comes to autonomous vehicles, self-driving cars, they can use cameras and vision to help navigate. When it comes to retail, smart stores that use vision to track products and detect theft. When it comes to security, computer vision uses facial recognition for access control and surveillance. When it comes to agriculture, drones can scan crops for health, hydration, and pests. And when it comes to accessibility, there are applications that can help visually impaired users identify objects or read text out loud. And that's just scratching the surface. Computer vision is essentially everywhere and is growing extremely fast. So how does computer vision actually work? Well, let's walk through the basic idea using an example. So say you want to teach a computer to recognize pictures of dogs. You start with a bunch of dog images. The computer doesn't see a dog in the way that we do. All it sees is numbers, i.e. pixels and color values. Now, through a process called training, we help the computer learn patterns that distinguish a dog from a loaf of bread or a bicycle. And the more data that it sees, the quote unquote smarter it gets. All right, so let's zoom in on two of the most foundational and fascinating applications of computer vision. And the first one we're going to talk about is called image classification. And then we're also going to talk about object detection. Now, both are related, but they serve different purposes. So let me go ahead and break them down. So let's talk about image classification first. So imagine that you give AI a photo and then you ask it, what is in this image? If the AI responds with just one label, like dog or pizza, then that's image classification. And if you want a formal definition, well, image classification, this is the process of assigning a label to an image from a fixed set of categories. So think of it like sorting pictures into folders. All the cat pics will go into the cat folder, all the car pics go into the car folder, and all the pizza pics will go into the pizza folder. So here are some real world examples of how image classification is being used. You could find it being used in Instagram and Facebook, where it automatically tags your friends. It's used in medical imaging tools for detecting whether a scan is healthy or abnormal. It's also used in wildlife conservation, where drones are used to classify animals and photos. And it's also used in email filters for recognizing and classifying spam based on images. Now, exactly how does all of this work? Well, behind the scenes, the process usually looks like this. So the first step is called data collection, and this is where you gather thousands or millions of labeled images. So for example, you have a bunch of photos that are labeled as cat, dog, car, etc. Then the next step is called pre-processing, and this is where images are resized, normalized, or converted to grayscale to reduce complexity. Then there's step 3, where you train the model. So you can use a machine learning model where they often use what is called the convolutional neural network, or CNN, to learn from the images. And then there's step 4, it's called testing and inference. So once the model is trained, you can feed the model a new image and it will predict the most likely label. All right, so the other pillar is called object detection. So image classification is great, but what if there are multiple things in the image? So say you're looking at a photo of a dog, a ball, and a tree. You don't want to know what's just in the image. You want to know what is there and where is it in the image. And that's where object detection comes in. And a formal definition of object detection is basically identifies multiple objects within an image and draws bounding boxes around them, labeling each object. So instead of saying there is a dog, the algorithm will say there's a dog at coordinates x1, y1, there's a ball at x3, y3, and a tree at x5, y5. And real world applications of how this stuff works. So once again, we have autonomous vehicles, and this type of technology can be used for spotting pedestrians, street signs, and other vehicles. It's used in retail, where it can detect products on shelves for inventory management. It's used in security cameras for recognizing people or unusual objects. It's also used in sports analytics, where it can track players, the ball, and movement patterns. And of course, it's used in smartphone cameras, where it can enhance autofocused facial detection. Now, exactly how does object detection work? Well, it's a bit more complex than classification, but let me go ahead and try to simplify it. Step one is called annotated training data. And this is where you need images with bounding boxes and labels for each object in them. So an example will be a person box, a bicycle box, or a dog box. Then there's step two. This is when you would train an object detection model. And some popular architectures for object detection include YOLO, SSD, and FASTER, RCNN. And these models basically detect and localize multiple objects simultaneously. And then there's step three, which is output. So you feed an image and the model spits out coordinates of bounding boxes. It also tells you the predicted object in the box. And then it gives you a confidence score. Like it'll say something like, I'm 93% sure that this is a truck. And here's a quick side-by-side comparing image classification versus object detection. So go ahead and take a screenshot and get that in your life if you need it. Now let's talk about some challenges that are associated with computer vision. So computer vision is powerful, but it's not perfect. And here's a few common challenges. The first is lighting and weather. So a model that is trained on sunny photos, it may struggle on rainy days. You have angles and perspectives. So an object viewed from a weird angle, this might confuse the system. You have what is called occlusion. So basically, what if there is a dog behind a chair? Will the AI still be able to recognize it? You have bias in training data. So if a facial recognition model is trained mostly on one ethnicity, it may perform poorly on others, which could lead to dangerous consequences. And then there's processing power. You have high-end vision models, especially those real-time ones. They can be super demanding. Now, these challenges are why researchers are constantly refining algorithms, data collection methods, and fairness metrics. All right, so let's go ahead and wrap this lesson up. So computer vision, this is the bridge between the digital and physical worlds. It helps machines recognize, understand, and interact with the world around them. It powers everything from Google Photos to robot navigation systems. And with tools like image classification and object detection, it makes things smarter, safer, and more efficient. But the journey doesn't stop there. So as you continue your AI fundamentals journey, just think about this. How would you want an AI to see the world? What data would you feed it? And how would you ensure it sees fairly and accurately? Because training an AI to see isn't just a technical challenge, it's a human one as well. And with all of that being said, let's do some check on learning. So our first question is, which of the following best describes image classification in the context of computer vision? Is it identifying multiple objects in an image and drawing boxes around them? Is it assigning a single label to an entire image based on its main content? Is it predicting the location of key facial features in a photo? Or is it tracking an object across a video stream over time? And the correct answer is it is assigning a single label to an entire image based on its main content. So image classification involves analyzing an image and assigning it to a specific label from a predefined set of categories. Unlike object detection, which can identify multiple objects and their locations, classification is about determining the overall category of the image as a whole. Next question. What is the main difference between image classification and object detection? Is it object detection works only on videos while image classification works on still images? Is it image classification labels every object separately while object detection labels only one? Is it object detection identifies both the label and the location of multiple objects in an image? Or is it image classification uses deep learning while object detection does not? And the correct answer is object detection identifies both the label and the location of multiple objects in an image. So, object detection not only classifies objects within an image, but also pinpoints their positions using bounding boxes. Image classification, on the other hand, classifies the image as a whole without locating individual items. And our final question: which of the following is a potential ethical concern related to computer vision systems? Is it using grayscale images instead of color for training? Is it relying on data sets that lack diversity, leading to bias recognition? Is it applying data augmentation to improve model accuracy? Or is it using convolutional neural networks for edge detection? And the correct answer is it is relying on data sets that lack diversity, leading to bias recognition. So, one major ethical challenge in computer vision is data set bias. If training data is not diverse, the resulting models may perform poorly on underrepresented groups, leading to real world or unfair treatment.